Installing a non-GFCI receptacle for the 24 volts irrigation system might not violate the National Electrical Code, specifically referring to Section 406.9b, provided specific conditions are satisfied. These conditions primarily revolve around accessibility, voltage levels, and equipment design. Firstly, the receptacle must not be readily accessible to unqualified personnel. This necessitates placement within a locked enclosure or a location restricted to trained electricians or authorized individuals. The intent is to prevent accidental contact or tampering by individuals unfamiliar with electrical systems, particularly in potentially wet or outdoor environments. Secondly, the irrigation system operates at a low voltage, defined as less than 50 volts. Since 24 volts falls squarely within this low voltage category, it inherently presents a reduced risk of electrical shock compared to standard 120 volts or 240 volt circuits. Low voltage systems are generally considered safer for outdoor applications where contact with water or ground is more likely. Thirdly, the irrigation system's controller and power supply must be specifically designed and intended for use with non-GFCI receptacles. This is crucial, and verification should come directly from the manufacturer's documentation for the irrigation system. The manufacturer's instructions and specifications often outline the acceptable electrical characteristics and protective measures required for safe and compliant operation. Consulting the manufacturer's documentation is a critical step in ensuring that the non-GFCI receptacle is appropriate for the specific irrigation system. Beyond these three conditions stipulated by the NEC, adherence to local building codes is also paramount. Local jurisdictions often impose additional requirements or restrictions that supersede or supplement the National Electrical Code. It is essential to research and comply with all applicable local regulations to avoid potential violations and ensure the safety of the installation. It's important to note that individual electrical inspectors might hold differing interpretations and may still mandate GFCI protection for all outdoor receptacles, regardless of the voltage level. This is a common practice driven by a conservative approach to safety, particularly in residential settings where unqualified individuals may have access to the receptacle. The most prudent course of action is to proactively consult with the local electrical inspector before proceeding with the installation. This consultation will clarify any specific requirements or interpretations prevalent in the local jurisdiction and ensure full compliance with all applicable codes and regulations. It is also prudent to document the consultation, including the inspector's name and date, to provide a record of due diligence in the event of future questions or inspections. The installation of electrical equipment, including receptacles, requires adherence to the National Electrical Code, local building codes, and manufacturer's instructions to ensure safety and compliance. Consulting with qualified professionals and local authorities is always recommended for complex or ambiguous situations. In addition to the specific requirements and considerations already discussed, several other aspects warrant attention when dealing with outdoor receptacles and irrigation systems. Grounding is a fundamental safety practice that should never be overlooked. Ensure that the non-GFCI receptacle is properly grounded according to NEC Article 250. Grounding provides a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. Proper grounding significantly reduces the risk of electrical shock in the event of a fault condition. Wiring methods must also be carefully selected to withstand the rigors of the outdoor environment. Use-only wiring and cabling listed for outdoor use, such as Type UF cable or conductors installed in rigid metal conduit, intermediate metal conduit, or PVC conduit. These wiring methods are designed to resist moisture, sunlight, and physical damage, ensuring the long-term reliability and safety of the electrical system. Consider the load calculation for the circuit supplying the irrigation system. Ensure that the circuit has sufficient capacity to handle the irrigation system's load, as well as any other loads that may be connected to the same circuit. Overloaded circuits can lead to overheating, nuisance tripping of circuit breakers, and even fire hazards. Follow the load calculation procedures outlined in NEC Article 220 to determine the appropriate circuit size and overcurrent protection. Surge protection is another valuable consideration for outdoor electrical equipment. Lightning strikes and power surges can damage sensitive electronic components in the irrigation system controller and power supply. Installing a surge protective device at the receptacle or at the service entrance can help to mitigate the risk of surge damage and extend the lifespan of the equipment. Weatherproof enclosures are essential for all outdoor electrical connections and devices. Use weatherproof boxes, covers, and fittings to protect receptacles, switches, and splices from moisture, rain, and snow. Weatherproof enclosures are designed to prevent water from entering the electrical system, which can cause corrosion, short circuits, and electrical shock hazards. Regular inspections and maintenance are crucial for ensuring the continued safety and reliability of the outdoor electrical system. Periodically inspect the receptacle, wiring, and connections for signs of damage, corrosion, or deterioration. Replace any damaged or worn components promptly to prevent potential hazards. Also, trim any vegetation that may be encroaching on the electrical equipment to prevent physical damage and maintain clear access for inspection and maintenance. When replacing a GFCI receptacle with a non-GFCI receptacle, it is essential to understand the implications for ground fault protection. A GFCI receptacle is designed to detect ground faults, which are small leakage currents that can flow through a person's body to ground. When a ground fault is detected, the GFCI receptacle trips, interrupting the circuit and preventing electrical shock. A non-GFCI receptacle does not provide this level of protection. Before replacing a GFCI receptacle with a non-GFCI receptacle, carefully assess the potential risks and benefits. Consider the location of the receptacle, the type of equipment it will be used with, and the likelihood of exposure to moisture or water. If there is a significant risk of ground faults, it may be prudent to retain the GFCI receptacle or explore alternative solutions for providing ground fault protection. Another factor to consider is the presence of other GFCI receptacles on the same circuit. If the circuit is already protected by a GFCI circuit breaker or another GFCI receptacle upstream, replacing a GFCI receptacle with a non-GFCI receptacle may not significantly reduce the overall level of ground fault protection. However, if the receptacle is the only point of GFCI protection on the circuit, removing it could increase the risk of electrical shock. In some cases, it may be possible to provide equivalent ground fault protection by installing a GFCI circuit breaker in the electrical panel. A GFCI circuit breaker provides the same level of ground fault protection as a GFCI receptacle, but it protects the entire circuit rather than just a single point. This may be a more cost-effective and convenient solution for providing ground fault protection for multiple outdoor receptacles. When working with electrical systems, always prioritize safety. Energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. In summary, the decision of installing a non-GFCI receptacle for low-voltage irrigation system requires careful consideration of NEC requirements, local codes, manufacturer's instructions, and potential safety implications. Consulting with a qualified electrician and the local electrical inspector is crucial for ensuring a safe and compliant installation. Don't forget to consider these extra points. Firstly, document everything. Keep records of manufacturer specifications, consultations, and any code interpretations. Secondly, use appropriate signage. Clearly label the receptacle as non-GFCI protected and indicate that it is for qualified personnel only. Thirdly, consider a regular inspection schedule to ensure the installation remains safe and compliant over time. This proactive approach will minimize risks and provide peace of mind. By paying attention to these details and seeking expert advice, you can make informed decisions about your irrigation system installation. Ultimately, your diligence ensures the safety of both the user and the equipment itself. Safety should be the utmost priority in every electrical project, so do not hesitate to seek guidance from qualified professionals. They can assess, the specific situation and provide tailored solutions to ensure adherence to all applicable codes and regulations. Remember, electrical codes and regulations are constantly evolving, so staying informed about the latest requirements is essential for maintaining a safe and compliant electrical system. Continuously update your knowledge and skills by attending training courses, reading industry publications, and participating in professional organizations. Knowledge is power, and it empowers you to make informed decisions and perform electrical work safely and effectively. In conclusion, the decision to use a non-GFCI receptacle for a low-voltage irrigation system should be approached with caution, careful planning, and expert consultation. By following the guidelines outlined in the NEC, adhering to local codes, and prioritizing safety, you can achieve a compliant and reliable installation that meets the needs of your specific application. If the fountain is not low voltage, it needs GFCI protection. As for the 120 volts power supply for the irrigation system, using a non-GFCI receptacle might be permissible under certain conditions. The NEC addresses GFCI protection in section 210.8, specifically dealing with GFCI protection for personnel. For dwelling units, all 125 volts, single phase, 15 amps and 20 amps receptacles installed in specific locations such as bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens and laundry areas require GFCI protection. It's important to note that the 24-volt secondary side of the power supply does not negate the requirement for GFCI protection in the 120 volts primary side if the receptacle is located in one of the areas listed above. However, Section 210.8 ATWO provides an exception for receptacles that are not readily accessible. If the receptacle is located behind an appliance that is not easily moved or is dedicated to a specific appliance, it may not require GFCI protection. In this scenario, the irrigation system's power supply could potentially fall under this exception if it's considered a dedicated appliance and the receptacle is not easily accessible. However, it's imperative to verify this interpretation with the local electrical inspector. It's crucial to consult the manufacturer's instructions for the irrigation system's power supply to determine if it requires or recommends GFCI protection. Some manufacturers may specify the use of GFCI protection to ensure proper operation and safety. If the manufacturer requires GFCI protection, then it's necessary to comply with that requirement regardless of the NEC exceptions. Furthermore, Section 406.9 Bone addresses the replacement of receptacles. It states that replacement receptacles must comply with specific requirements, including GFCI protection if the original receptacle was required to be GFCI protected. However, there's an exception for non-grounding type receptacles in existing installations where a grounding conductor is not available. In those cases, a non-GFCI receptacle can be replaced with another non-grounding type receptacle. When replacing a receptacle, it's essential to carefully assess the existing wiring and grounding conditions. If there's no grounding conductor available, you can't simply install a GFCI receptacle and rely on it for proper protection. In such cases, you'll need to explore alternative solutions, such as running a new grounding conductor or installing a GFCI circuit breaker. Always prioritize safety and consult with a qualified electrician to ensure that the replacement receptacle is installed correctly and provides adequate protection. In addition to the NEC requirements and manufacturer's instructions, local codes and regulations may also have specific requirements for GFCI protection. It's essential to research and comply with all applicable local codes and regulations to avoid potential violations and ensure the safety of the installation. Some local jurisdictions may have stricter requirements for GFCI protection than the NEC, particularly in outdoor areas where exposure to moisture is more likely. Contact the local building department or electrical inspector to obtain information about local codes and regulations. Furthermore, consider the environment where the receptacle is located. If the receptacle is located in a damp or wet location, it's more likely to be subject to moisture and corrosion. In such cases, it's even more important to provide adequate protection against ground faults. Consider using a weather-resistant receptacle and cover to protect the receptacle from the elements. Additionally, ensure that the receptacle is properly grounded to provide a path for fault current to return to the source. Grounding helps to reduce the risk of electrical shock and provides a more stable reference point for the electrical system. Remember that electrical codes and regulations are constantly evolving, so staying informed about the latest requirements is essential for maintaining a safe and compliant electrical system. Continuously update your knowledge and skills by attending training courses, reading industry publications, and participating in professional organizations. Knowledge is power, and it empowers you to make informed decisions and perform electrical work safely and effectively. In summary, the decision to use a non-GFCI receptacle for the irrigation system's power supply requires careful consideration of NEC requirements, manufacturer's instructions, local codes, and environmental conditions. Consulting with a qualified electrician and the local electrical inspector is crucial for ensuring a safe and compliant installation.